So welcome everyone. My name is James Serra. This presentation is Data Lakehouse, Data Mesh, and Data Fabric. I am currently I've been in Microsoft for most of the last 8 years. I'm currently at a group that I moved in early this month called Microsoft Federal Civilian. In Microsoft, we have a bunch of industries, healthcare, finance. We also have federal. And that's where I recently moved as sort of a cloud solution architect in their focus on data and AI. I've been doing this quite a long time. I won't go back to my COBOL days, but at times I've been a DBA, a developer. I use SQL Server since 1.0 on OS2, and have the last couple of years has been a lot of confusion with customers on different approaches for architecture. And that's where I created this presentation to talk about, well, what is it exactly a data warehouse? What is a data lake? And then when we get into architectures, we have these modern data warehouse, we have data fabric, data lakehouse, and a lot of talk lately on data mesh. And this is something I present a couple times a week, usually to customers and as well as people within Microsoft to try to help them understand what these concepts are and then what these architectures are. And I'll have to say that these are my interpretations. It doesn't mean Microsoft has the same view. And in many cases, I don't even know what the Microsoft view is, but I just put this in there because I've gotten kind of trouble, people going like, oh, Microsoft said this when it was really me saying this. So just to clarify that. And by the way, just drop in questions in the chat. I'll be monitoring that, and I'll take pauses to review them and answer whatever questions you have as we go along. I'll make this deck available afterwards, so you have a copy of that. And you know what they say about assuming. I'm assuming people most know about a data warehouse, but in case you don't, there are many reasons why you want to have a data warehouse in here. And even if you do understand what a data warehouse is, there's a lot of confusion on with these new approaches in data architectures, you still copy the data, and the answer is a strong yes, just for the reasons here below. You want to avoid stressing the production system. You want to copy the data and optimize it for read access. You want to keep the history of the data on there. You want to rename the tables and the fields to make it more presentable to the end user, because the ultimate goal of any architecture you build out should be self-service BI. Make it really easy for the end user to create reports, so they're not going to IT for everything, and then IT becomes report writers on there. So lots of reasons why you want to have a data warehouse, which is copying all these source systems into one central location. And also in these architectures, even some that the data mesh that doesn't copy everything to a central location, you're still going to have a copy of the data even in that location wherever it is. And we'll get into that. But if you're not familiar with data warehousing, go through these and you'll understand why you want to copy the data instead of running and reporting all off the data warehouse. Good. So you struggle with these concepts. And then there's, okay, data lake. And there's a lot of customers who go like, I don't really understand why would we need a data lake, or what's the point of it? And data lake, the concept of it is, think of it as a glorified file folder. Nothing different than you have a folder on your laptop in there. And why do you have this in the cloud? So you create this data lake that's these files and folders, and there's many reasons in here. And these are just 5 of them I put up in there. But one of them is it's easy to land data in the data lake in there. So if you think of a data warehouse or that you're going to copy data in there, you're going to have to create a database, create a table, create the fields, a schema, write the code to copy all the data in there, and that can be a lot of work. With data lake, it's like copying files in your folder in your laptop. You just land it in there. Now, when you pull it out, you have to understand the schema, and we'll get into that. But it makes it really easy to get data into a location very quickly. And if it's in the cloud, and you're using something like Azure, you get immediate high availability. It gets 3 copies of of anything you write in Azure. So you have that high availability built in. It's easy to do disaster recovery. And that gets into a whole other topic of why put data in the cloud. But when you have your data lake in the cloud, it's got all that high availability disaster recovery built in. A big reason for a data lake is if you have a relational database, and I did this a lot when I was a DBA. You have a maintenance window, and you're copying all this data into these staging tables inside the data warehouse, and then you run stored procedures and ETL to load data in there, and then you hopefully it finishes by the end of the maintenance window, and then you copy it into the production tables. And if something goes wrong and you have to keep rerun the ETL, now end users are upset because you may miss the maintenance window in there. Plus, it's pretty expensive when you're using the compute on a relational data warehouse, and you're limited to that compute in the relational database product you're using. With the data lake, you can think at the very least is you take those staging tables and you put it in a data lake, and you do all the loading and cleaning of the data outside of the data warehouse. So you get rid of your maintenance window. You can run 24/7 with your data warehouse people querying it and reporting off of it. And all that transformation is done in this data lake. And you can use any sort of compute you want because the data is sitting in a folder, and you just need a product which can access data in data lake, which they can all do. And then you can use cheaper compute if you wish than what you get in a relational data warehouse in there. So it could be something like Synapse. And also, if you want to spend more money, you can have more compute. You can as much as you want. You can fire up hundreds of Databricks clusters if you want to clean the data. So you have that option on there. So that right there is reason enough that a lot of customers go in to use the data lake in there. Also, I can land data in very quickly. And if I have an end user, a power user, a data scientist who is technically apt enough, they can go and quickly query that data and get value out of it without waiting for it to go into the relational data warehouse in there. And that's where the tools have become easier to use. And we've talked, I saw the session before is on serverless. So you can dump a file in the data lake and quickly use serverless to see what's in there. And you can use it, explore, you can see if it's got value before you actually go to the trouble of copying it to relational data warehouse. You can use it for one-time reporting. Maybe data scientist says, I just need it in the data lake to build my models in there, and so it's just a quick way to get value out of that data in there, and you also save all that trouble of when I was a DBA too. Is sometimes you'd go through all this trouble of putting data in a relational data warehouse because the end user said this data is really important, and then you do all that work, and then the end user goes, well, actually, it's not that important. That data, you can delete all that stuff, and you wasted all this time. Well, now you can put it in to a data lake, and you can have Power BI access that data lake, and they can look, the end user can look at that data beforehand, before you go to all that trouble and see if it's got value. And maybe they can even, that's it, they can just run a one-time report. And we'll get into why you still want to copy it into a relational database. But because of the tools that have come so far, there's a lot you can do with the data lake now, which we'll get into our data lake approach in there. So those are just some of the reasons why you want to have a data lake. And really, and there's always exceptions to everything. And it depends on your data, the size, the speed, and the type. But almost all the customers that I deal with are building data lakes in there. So it's a big part of any of the data architectures we talk about. So Christopher has, it seems to me that ideally all data would be inside the data warehouse, but realistically that's never the case. And that's why we have to do things like data lake, data mart. Yeah, and that's very true in there. If we had a powerful enough relational data warehouse in there, we can put everything in there, and that'd be the end of our world. But that's not the case anymore, especially when we start to get into things like Twitter data and IoT devices and all that. And we'll run through some of that. But gone is the world where you just have one technology. Now everybody's building things with multiple technologies. So if we wind up with having a data lake and a data warehouse together in a solution, how can we separate out what the functionality of each are? Because there's some overlapping things. And so I break it out into these two lists in here. So think of your data lake, and at the very least, it's going to be the staging and prep area. and the data warehouse will be serving security and compliance areas. So if you look at this list, you'll say data lake's generally going to be for the power users, data scientists. It's going to do your refinement and cleaning in there. It's a place where you can store older data or backup data to it. You can schema on read, so you can do one-time reports. A lot of it, people use the data lake when they don't know the questions to ask. They have this data, let me go and explore it, play around with it, and see the value of it. Compared to a data warehouse where by the time the data gets in a data warehouse, you know the questions to ask. You're setting up the data warehouse to generate, to help fill in data, a little early for me. You're using the data warehouse to have as a source of reports and dashboards on there. And you'll get additional features in a data warehouse that are not in the data lake, like certain security, like row level security on there. It generally supports higher concurrency. And if you get into MPP technology that Synapse has in there, you can get much faster performance out of the data warehouse in there. So this is not the be all end all. You can mix and match functionality in here. But if you're going to use both of these in a modern data warehouse, which is our first architecture, think of it as this kind of separation. And so we get into the first data architecture, which is a modern data warehouse in here. And I intentionally kept this as a whiteboard because generally you want to use a whiteboard and discuss what the architecture is going to be. And no architecture is going to be useful for everyone in there. There's always exceptions to it because there's so much different variations of data on there. So this is a modern data warehouse. This is one architecture that you could look at, but I don't put certain things in here because it can be overwhelming in here. So I keep it to the basic functionality of a modern data warehouse. And I break it up into 5 steps. You ingest the data, store it, transform it, and model the data, and then you visualize it. And most people, architects, will break it out into these 5 steps. They may call it something differently, but the idea when you start out with is I need to ingest this data, and I have multiple sources. And in green here are the products that are used. Now, most times when I whiteboard with customers, I don't put any products on here until the very end, because it's going to depend on their skill set, what products you're using. So in this case, I have the Azure products, and in particular, Azure Data Factory in here, but you can put in other third-party products like Informatica if you want. But the idea is you have to take all this data, and you're using ELT. I'm extracting it, and I don't want to transform it as I'm on the fly because I want to minimize the time in the source system in there. So I extract it and I land it into a data lake. So that's where we get in part 2, we store it. And this is in Azure, we would use Azure Data Lake Storage Gen 2. And this is where we get into a much larger topic of data lake design on here. But the basics of it is you're going to have layers where, and this is where the functionality is similar in all the way people name these, but I name them raw, clean, and presentation. Databricks will use the medallion where it's silver, gold, bronze, silver, and gold on there. But the idea is all the same. It's going to land in this raw layer, and I'm going to then get to step 3 where I'm going to transform it. So I'm going to take all that raw data, put some compute on top of it, clean the data, and land it back into the data lake into the clean layer. And I may want to do more to it to make it presentable. So I may go from the clean layer, which also can be a conform layer where you're taking data that could be in CSV files and JSON and Parquet, and you're making it all one particular format. It could be, say, all Parquet, which is the most popular now. And then that may not be enough because you may need to join the data and aggregate it, maybe create a star schema, and you land it into that presentation layer. And then you may also have a sandbox layer because maybe a data scientist wants to copy the data and they can do with it what they want. And so you have that functionality inside the data lake in there because storage is really cheap and it's anybody can access it as long as they can get to the cloud. And that's what's great about having a data lake in the cloud. And within each of the layers, you'll have folder structures. Again, another long topic, but you got to think through data lake design, because you want to separate out the files and not just have them all in one folder. Maybe I separate it out for performance reasons, for security reasons, for convenience reasons by subject and all that. And each layer can have different folder structures in there. And for that cleaning, this is where we get step 3, the transformations. This is where you have a multitude of compute options in there. You can use Azure Data Factory data flows. You can use Databricks. You can use Synapse Serverless and use T-SQL and transform that data. And most customers use a combination of all these in there. A lot of customers, again, depend on your skill set, but if they don't have a bunch of Spark developers in there, they may say, well, we use Data Factory data flows because it's very easy and visual, and that'll work for maybe 89% of our cases. But maybe we have 10-20% of the cases that need more functionality that you can get from Spark, or need additional performance, or have to use some special library on there, and then they'll use Databricks for that. And then a lot of customers are starting to use Synapse Serverless because they have developers who are using T-SQL and like it, and so that could be an option that's mixed in there. Now, the presentation layer may not be enough for all end users to be able to generate reports from. So what happens then is you take that data from the presentation layer inside of the data lake. This is the model phase where you copy it into a relational database management system, which can be Synapse dedicated pools. And you can copy that over in third normal form. Then you can go another step and you copy it into a star schema and keep it in Synapse in there. And now what you're getting is, when we get to step 5, is somebody in Power BI can easily go to a workspace in Power BI and drag fields and create reports and dashboards. They don't have to about joining the tables in there. They're all easy to understand. And here's where the trade-off is. You're copying the data multiple times. Yes, you're adding additional ETL, additional costs, additional complexity, but the benefit is the data is in a format that's really easy for the end user, that's self-service BI. And this is where we're getting to different architectures. We're trying to reduce the copies on there, but this data warehouse has been around for a while and will continue to be, because of the people are used to the relational data warehouse in there. We'll talk about this in a second in more detail. But keep in mind that you don't have to copy all your data in the data lake into a relational database, into Synapse. You could just say, hey, maybe a lot of users are fine with it and being in the data lake, but there's certain end users that need it in the relational database for various reasons we'll talk about in there. So you'll copy a subset of that data over on that. So that's it at a high level. There could be lots of exceptions in here. I'll sometimes whiteboard. Well, a customer will say, well, I have a very small file that's from a source system, and do I really need to copy in a data lake? No, you can go right into Synapse for that, and as long as you understand all the trade-offs on here. And so this is where this basic architecture become very fluid. And if you'll notice on here, there's certain technologies that I didn't put in here, like real-time streaming in here, and this is because what I call an evolution of the modern data warehouse is the data fabric. And again, this is my opinion, and some people have very different opinions of data fabric. Some people call the modern data warehouse a data fabric. The way I define it is just think it adds a lot of additional functionality to it. Things like more details on security, access, and policies that you can put on there. You add in a metadata catalog. In the Microsoft world, that would be a purview, where you have lineage in there. You can add master data management, which is used in most solutions, and to avoid duplication of, say, customer records, and use products like Prophecy in there. You can get the data virtualization, which is a big topic on its own, but that could be part of a data fabric. Real-time processing in there. So now we start to get into things like event hubs and Azure Stream Analytics. So think of the data fabric as you're expanding out the ability for your solution to access data, no matter what the size, speed, or the type in there. It's a fabric. It's using tentacles. Maybe I'll call it an octopus, data octopus. Oh, I just thought of that. And because the idea is you want to build a solution that can handle data for a long time in there, not something 6 months down the road you're going to like, oh no, this is not going to work because we didn't think about this data on here. So the data fabric is making that more powerful that solution in there. With the trade-off, it's going to take more time to build. And the data fabric also can have more data scientist tools involved with it. It can have APIs, meaning instead of having to use a connection string, you can build a data fabric that here's all the API calls to get the data you want, and you can use that within your tools and applications and whatnot. You can also build a data fabric out and building blocks as sort of like a product. So maybe you create a great ingestion piece in data fabric, and somebody in your company says, I don't really need that data fabric, but you have that data ingestion piece. Can I use that code? And so if you built it in a way that you can share that code or create a service in there, that can be part of what I call a data fabric. All right, I'm going to pause there. If you have any questions, just type them in. So hopefully that makes sense on here. And you can sort of mix and match data fabric and modern data warehouse, because both of those, and keep in mind, both of those solutions are using a data lake and a relational data warehouse in them. So that's an important thing that's changing in the next architecture. If we go back in time for a 1-minute history, for those as old as me, you remember in the late 80s, we had these data warehouses. Teradata was a big one, and then later in the Netezza, these giant MPP technologies that can handle massive amounts of data. Of course, back at that time, massive amounts were like 1 terabyte. And when I started Microsoft, I was helping to sell the parallel data warehouse, which was a MPP on-prem solution in there. And in the 80s and 90s, that's all you had was relational database. And then this data lake concept came out in the late 2000s. It's not actually that old. It's like 15 years old. And the data lake came as this sort of savior, and you can land all your data in a data lake, and it's this land of unicorns and rainbows and throw in a few leprechauns, and all the data would be made available quite easily in there. And we don't need relational databases anymore. And I dealt with clients who went to this approach, and it was a big failure in there, because they would go to customers, especially at the time, the technology was not anywhere near it was today, and they would say, hey, we have the data in a data lake. It's in these folders. Go use Hive SQL and generate reports from that. And end users were like, look, I'm just an auto mechanic. I don't know any of this technology stuff in there. And so it blew up. And if you remember, we had multiple data vendors, and this was all because this was all in Hadoop. So we had multiple Hadoop vendors, and we had 2 of them, the big players, go out of business. And the data lake still stayed around, but it changed its main functionality to not be the be-all, end-all on there, to be combined with the relational database, to get the best of both worlds, as we just talked about, and that's the modern data warehouse. A few years ago, this concept of the Data Lakehouse came about. It's a combination of a data lake and a data warehouse in one. No relational database, just a data lake. And your first reaction should be, wait a minute, that failed miserably. What's changed? Well, what's changed is new technology came out called Delta Lake, first brought up by Databricks, who since open sourced it, so anybody can use it in there. And so what Delta Lake, it gives you is additional functionality on top of your data lake. So it's not its own storage, it's just software layer. Think of it as a storage software layer on top of whatever solution you're using. In this case, in Microsoft world, is Data Lake Storage Gen 2. And to use Delta Lake, it's simply, if you're writing code in Spark, on the right-hand side, you see you can save it as Parquet. You just change it to save it Delta. And the software layer takes care of the rest. And what that does is it gives you features on top of a data lake to make it like a relational database. It gives you ACID transactions, support for that. Support for time travel, data versioning as the data comes in there. It unifies streaming and batch, so it makes it easier to use both of those without having different technologies in there. It enforces schema. That's a big one, because if I'm having ETL and I expect all the files in a folder to be the same structure, and somebody throws in something that's way off, and my ETL will blow up. This Delta Lake can make it that it'll kick that out before it lands in there. So that's the benefit of schema enforcement in there. So it gives you and a big feature that gives you is the biggest feature is support for commands delete, update, merge, which doesn't exist in a data lake. So you have to do a lot of work to update data in a data lake, where in a Delta Lake, you can just have update statements and you can update pretty quickly the files sitting in there in the folder on there. And it's pretty performant in there. So that is a big change because now I can do all this updating of the data as it sits in a data lake in there. It also, Delta Lake gives you a lot of performance improvements, and it solves things like the small files problem for those who are aware of that. So great, Delta Lake could be a savior, but everything in life has trade-offs, which we'll get to. And so Delta Lake has really 4 great reasons to use it. It means you can get rid of these 4 problems. The reliability of having to keep the data lake and relational database consistent. Imagine if your ETL blows up and or it's got a bug and now the data lake can have different values than what's in the data warehouse. The data warehouse is going to be older in the relational database. It could be a day old or an hour older, but it's still older than what's in the data lake. That can cause problems. Most data scientists like data in a file folder format in a data lake. So more machine learning tools support data in a data lake. So this is a good reason to do everything in a Delta lake. And then you only have 1 copy of the data on that. Now, storage is pretty cheap, but hey, you're still saving money by not having to copy it over into a relational data warehouse. But there are trade-offs. And I was having this conversation yesterday. I said, every technology's got trade-offs. So anytime you hear about a new technology, a new architecture, that sounds great, dig into what the trade-offs are. In the case of a data lakehouse, which we're opening a can of worms, there's these concerns. One of them being speed. Queries are just always going to be faster in a relational data warehouse, especially if you got massive parallel processing like you have in Synapse Dedicated Pool, because you have indexes and statistics and caching and query plans, all these things that don't exist in a Delta Lake in there. Now, that could be fine if it's slower. Maybe it takes 5 seconds and you'll go like, that's fine for us. But if you have SLAs and data needs to be in a second or less, you're not going to get that in the Delta Lake. So that's where that data should be copied to a dedicated pool to get you the performance you need. In Delta Lake, there's no concept of row security, column security, dynamic data masking. There are always workarounds, but they're very troublesome and problematic workarounds on here. A Synapse has all this built in, so it's out of the box, easy to use. And if you need this additional security, this is where that data obviously should be copied to a relational data warehouse. It's in a Synapse dedicated pool. A lot of people struggle with having metadata separate from the data. And so the good thing about relational database is you're locked in. You can have the metadata and then you're going to have the data. No way around that. It makes it easy to navigate. And yeah, it's extra upfront work, but it helps the end user find that data. Where in a Delta Lake, the metadata could be anywhere. It could be in some separate file. It could be within the file itself. It could not even exist. So that can make it really hard for people to understand the data and find it. And it suffers against the Delta Lake concurrency compared to a relational data warehouse. You don't have features like referential integrity. If you're using a Delta Lake in Databricks, you're going to have to use Spark SQL, which is pretty close to T-SQL. Doesn't sound like a big deal unless you have 1,000 developers who are really used to T-SQL. Now you have to train those people. So take that into consideration. That could be more work than it's worth, and you may want to keep data in a relational data warehouse. And the products must add Delta Lake support, so that could be a problem. Now that's gone away for a lot of products in the Microsoft world. Really, all of them support Delta Lake, but third-party products may not. So you got to look into that. And then just the fact people are used to relational database. Like I said, you're forcing that metadata layer on there. Now this has changed recently with some of the products Microsoft has to address some of these concerns in there. So if you think of Synapse and serverless piece, is that allows you to use T-SQL over data sitting in a Delta Lake. So some of the sessions went over this before, that I can have a file and I can just have a view that points to that file, and that view has the metadata within it. and a person end user can use that view even within Power BI and use T-SQL because they're using a view that is T-SQL, and then serverless supports that. And to the end user, it appears that the data is sitting in a relational database, but it's actually in this file. So that's where some of the concerns like having to use Spark SQL goes away. And if you're using Power BI as part of your solution, Power BI can import the data, and Power BI has role of security. So that's another concern that can go away if you're using that product on here. And this is where Microsoft's going in the future direction, is more focus on the data lakehouse because of not having, the reason I said before, not having copied the data and staleness in there. So there'll be more, you'll see more work come out in future products that will address these concerns. Will it address all of them? Probably not. But there may be a situation where, as an end user, a customer, you go, oh, actually this data lakehouse will work well for us. We don't have to, these concerns are minor, or we're getting rid of these concerns on there. The whole point is just to be aware of these concerns. And some customers, I say, do a data lakehouse until you can, until you find a reason where, oh, we're not getting the performance we need, as an example. And just for that data, we'll copy it over into a relational data warehouse in there. Okay, so question, which term will dominate the next 5 years? Will it be data lakehouse or data mesh? Oh, boy, that's a loaded question on here. So let's go through a data mesh, and then I'll answer that. And you could probably answer that and tell me what you think is gonna exist in the next 5-10 years. And she says, don't see many use cases of data mesh done effectively, what you take for the next 5 years. Yeah. So I agree with that. So let's get into our next topic. We have 10 minutes of data mesh in here. So the big difference between all the architectures I talked about in data mesh is this decentralization. Everything I talked about was copying the data into a central location. It's owned by IT, and it's most likely physically in the same location. Where a data mesh, the concept at a very high level is decentralize that, not copy it all into one location, not have IT own all the data. Now, I have to point out that data mesh is a concept. There's no technology. If you read Zamek's, and she coined this term, it wasn't new concepts, but she packaged it up really nice and had a great blog on that. But there's no how to build this. It was all a concept. And it's much more an organizational and culture shift than anything on here, which a lot of companies cannot do. So that's where, right off the bat, it's tough for a lot of customers to even think about a data mesh, because they're not at a point where they can have a big shift on there. And also, there's been a lot of hype of data mesh. So it's not a magic wand you can buy on eBay. There's no data mesh in the box on there. So I want to point out what Gartner says. There's a big hype cycle on this, and data mesh is going to have that trough of a disillusionment, they call it, pretty soon. And they say the penetration of data mesh be 1 to 5%, which I agree with. I think 1% is more where you're going to see that amount of customers using data mesh. It's so hyped, but it's only a use case for a very small amount of customers, and we'll get into why that is. Data mesh is just 4 principles, and I'm going to say it took me a long time to understand what a data mesh is, which is one of the problems. I always say you talk to 10 people about what a data mesh is, you'll probably get 11 different answers in there. And even to this day, I'm still going back and reading her blog and coming up with different interpretations of some of the things she wrote. But at a high level, it's these 4 principles. The first is domain ownership. The idea is each organization each company has organizations within it, manufacturing, sales, suppliers, examples. They, in a data mesh, maintain ownership of the data. Instead of them copying all the data to a central location and IT now owning it, they keep ownership of that. So they're the ones that know it best. They're the ones that should clean it because they know it best. So that each organization, which we call domains in a data mesh, own the data. Because they own the data, that means they have to treat data as a product, meaning they have to have their own domain teams. So they're going to have their own IT. They're going to have to write some interface that people can use to get access to their data. So maybe it's API code that they write, and people outside their domain can call those API to get the metadata of what they have and then to get the actual data. And then they're going to have to build up the infrastructure for all this. So they own it and then they keep track of it. And inside of data as a product, they may have all these source systems. They may create a data lake and even a relational data warehouse in there, because they're the ones, each organization, that's got to provide the data in analytical format for other people outside of the domain to use. Now, this gets into, as you can imagine, is we can't have all these domains going and building their own solutions. We have to make it easier for them. So can we do self-service data infrastructure as a platform? The idea is, can we create some code or scripts that ideally they press one button, it asks them what they want to call their domain name, and it builds out the storage and the compute and the ETL and the security on there. There's no product that exists like this. Microsoft has products that help a little bit on this, and this is where it's really a struggle, because if each domain is going and doing their own thing, it's going to take forever to build a data mesh in there. So and this is where it gets confusing, can somebody that's centralized create the scripts for this? And this is where it gets confusing. And so you're still going to have some centralized things. One of them being somebody, the group that built up the infrastructure, the scripts and whatnot to build the domains for this. You're also going to get into principle 4, where you're going to have a centralized team that is going to govern all the domains, because you can't have them going and doing their own things when it comes to security, and they all come up with different ways of securing the data, or even different ways of cleaning the data. And who's following? Are they all following the regulations? You have to have an overriding board or a group that is going to distribute all the standards to all the domains and then monitor it to make sure everybody's following those and handle discrepancies between all that. So that's the 4th one. And so when you think of the 4, the 1 and 2 are decentralized, but 3 and 4 are centralized. And this is where people got confused on that. So it's not a complete decentralization. 3 and 4 are centralized. Now there's variations that you can say, well, I'm going to take people in the domains, and that will be the group that is centralized to come up with, say, standards in there. But the bottom line is there needs to be a centralized group that is watching everyone else. And so the use case for data mesh is it helps data ownership. Who owns the data? Now it's the source team, the domain, the org on there. It solves the problem of quality. At least this is in theory. It improves the quality because the people know the data best are cleaning it. It provides, and this is the big one, organizational scaling. As I add more data, if I'm using another approach, IT becomes the bottleneck. We can't have enough people. So now we solve that by having domains that hire their own teams. And so we get more domains, we have more people in there. So that's the way we can scale organizationally. The same thing with technical. Instead of having IT have their own technology and everything goes into that one technology, now each of the domains have their own technology. And so more domains, more technology, more storage, more compute on there. So we're solving that problem of technical scaling, at least in theory. And data domains, you hear the 3 Ds, data domain design, and this is really complex. It takes a long time to come up with the way your organization should be broken out by domains. And I've seen companies spend a year, sometimes more, to come up with these data domains, which is a problem on there. But you have to do this in order to create a data mesh, because each of those domains become their own mesh. And so what you wind up having is, this is where it gets confusing. You can have domains like manufacturing, sales, and supplier that are source aligned. So if you're within that domain, you understand the data, but it may be difficult for people outside the domain to understand it. So Zamet came up with, well, we'll have consumer aligned domains too, where you can copy the data from source aligned into consumer aligned, and consumers then will access that data. You can also have aggregate domains, because it could be performance issues. If I need to combine, say, manufacturing and sales to come up with a P&L, if I'm doing that on the fly, that could take forever. So copy the data, aggregate it, and put an aggregate domain, which then runs into the problem of who owns that domain. So this gets away from sort of the pure data mesh in there. And one of the things I have a problem with is once you do this, you're gonna have to have arguments like you have without the data mesh of who owns that data. And then things get complicated because domains, you don't want each domain repeating the same old thing. You don't want them all mastering customer data. So you have domains and you copy data from one domain to the other. That's why you have all these lines coming in here. And you may even come up with something like a 360. So instead of each domain mastering the data for customer, you have somebody do that beforehand, and then that gets distributed out all to the different domains. So this brings up a lot of concerns. You probably already thought of some of these as you're going along. What is a data mesh? What is a minimal viable data mesh? I have those 4 principles. If I create a data mesh and I'm only using 3 of those principles, is it actually a data mesh? If I'm only using 2 of those principles, which I see a lot of companies doing principles 1 and 2, can you call it a data mesh? I would probably say no, but people are calling data mesh. So this leads to confusion. I've seen people say, I'm going to use virtualization software to access everything, and I have a mesh. Well, that's not following any of the 4 principles on there. Hence that confusion in there. And then you have problems like, well, what happens with if a domain says, I don't want to wait for a data mesh, I'm plowing ahead. Or, wait a minute, you're telling me I have to create my own IT team and I got to do all this work now? I can barely keep bulbs running in there. I'm not going to do that. Why should I do that? And your response is, do it for the greater good. They're going to go like, I don't care about that. Well, now what do? You have one company that's not, one organization that's not doing a data mesh, and you're kind of, okay, well, I can't ignore that data. What am I going to do? And even Zamek in her book said these are the reasons you should adopt data. Should you adopt data mesh? These are the things, the categories you need to score medium or high in. And right away, off the bat, many companies are going to say data mesh is not for me because we're not tech at core. We're not early adopters. We don't have a domain-oriented design in it. We don't have a long-term commitment. So the more people looking at data mesh, the more they go, oh, okay, this is not right for us. Now, the good thing that comes out of data mesh is you get thinking about who owns the data. And so there's some of the concepts out of there that can be applied to other architectures that I talked about that you may use instead, but at least it got people talking and thinking about getting the best use of data. Now, data mesh on Azure, this is a very quick slide because it's a concept. And Microsoft has, think of principle 3, the scripts to build out part of your solution. That's what we call cloud scale analytics, which could work for even a centralized approach. But the idea is this will help you build a data landing zone and a management landing zone that will look like this. I have this management landing zone that's overseeing all these landing zones. And these landing zones could be, each of them could be their own domain. And each of those domains has their own technology in here. And so that's Microsoft's approach to helping customers build the data mesh, is to give them help with principle 3. But a lot of times we're also giving them help to understand the cultural shift that's needed, to understand how to do data domain design in that. So there's a lot of it is not technology, but rather people and process on here. And the last thing I'll bring up is everybody's got different approaches for a data mesh. Some of them you may not even call it data mesh. At the end, you'll like actually a data lakehouse. But if you look at the very left, you have data mesh type 1. The idea is all those domains are going to use the same technology, and the data is kept within one enterprise data lake, instead of all of them having their own separate data lakes. But what you do is you logically separate it out. So I can have one storage account or a container, and I have folders. Each of those folders are for each domain, and only they can access it. So logically it's separated out, but physically it's one location. And that solves a big problem of performance, because if you go to mesh 2, where every domain uses the same technology, including storage, but they have their own data lakes, now is how am I going to join all this data together? And that's one big problem with the data mesh in there, is somebody's going to need to join the data from a lot of these domains. And if they all have their own data lakes, which could be all over the world, that could be very challenging in there. So that's where we got into the aggregate domains, and it's just a lot of, you're getting away from the pure concept of a data mesh when you do that. But and so some customers are doing type 2, most are doing type 1, but nobody's doing type 3, because a pure data mesh could say, hey, each domain can use whatever technology they want. They can use whatever storage they want. So that means I could have some domain using Azure, one using AWS, one using Google. Even problematic if they're all using Azure, but one of them is using SQL database, one of them using SQL Synapse, one of them using Cosmos DB. Imagine trying to do principle 3 and 4, create scripts to build this out. or to manage all this. Now they're all doing different security. So this is where I don't think you'll ever see data mesh type 3. And then finally, my thought of the future is, I think what you'll start seeing is a centralized approach for a lot of the data. And then as new data sources come on board, you may see them as a data mesh. And so it's more like a hub and spoke. And maybe some of the centralized data solutions will become data meshes, and you'll move more of that data, have more data meshes. But as I said, it only takes one org or domain to say, I'm not building out a mesh. So you're forced to use a centralized data solution. So this is what I think you'll see. And I still think a lot of customers won't even go this route with the data mesh, but if they do, it'll be more of a hub and spoke model, and nobody will ever have a pure data mesh. I would think. I'd be surprised if that ever happens in there. And so in the end, there are customers that are building data mesh. It takes multiple years to build one out. Everybody's got exceptions. Nobody's got a pure data mesh that I've seen yet. And the last thing I'll mention, when I was at the past summit, there was about 100 people in my session, and I said, how many of you know what a data mesh is? And I would say about 80% raised their hands. And I said, how many of you have a data mesh in production? And not one single person raised their hand. And that's been consistent. It's just not at a level of a lot of customers building out. Not that it's a bad concept, but it's only for very specific use cases. All right, that's it. So to answer the question is, sometimes I think we may 10 years from now, 5 years from now, go like data mesh. Oh, remember that thing? I think it's going to evolve into something different, and maybe people still call it a data mesh, but I don't think the pure data mesh is going to be around for a long time. I think there's too many technical challenges, and there's too many cultural challenges in it. So there'll be some variation of it. All right. That's it. Any other questions? Feel free to type them in, come off mute. Hopefully that gave you a quick high-level understanding. I'm actually writing a book on this, and I'm about halfway through it, and to go more deep into these. And I also have more on my blog about some of these topics. Feel free to send me an email if you have follow-up questions. Happy to have conversations. As part of my job at Microsoft is to educate people. So I know this is a lot, and I do this with customers, and sometimes their heads get steam come out of it when you do this for 4 hours. So I know it's a lot to consume. So happy to answer your follow-on questions on that.